Hi, this is a video for Basadi. She wants help with the 9701 stroke 12 May June 2022, and she's got 5 questions she wants to go to. And let's go. Number 26. What's the total number of stereoisomers, including the one shown? Right, so this double bond has 0 because these two groups are the same. This double bond has 2 cis and trans, and this one has 2 cis and trans. So you can have cis, trans, cis, and trans. So in other words, it's 2 times 2, so you can have 4. But then, just to make it interesting, this is also an optical center. So this is another 2 involved. So it's 2 times 2 times 2 equals 8. And the answer is 8C. Okay. Next one. Oopsie daisy. Next one. The molecular formula CH3 can represent an anion, a cation, or a free radical. Species with the molecular formula CH3 could be electrophiles, nucleophiles, depending on the number of electrons in the outer shell. How many outer shell electrons on the central carbon atom must be present for CH3 to react in these different ways? So let's do CH3. You can have this. You can have this. And you can have this. These are 3 ways the CH3 can be. First one, an electrophile. That means it's going to be positively charged. Okay, if it's a free radical, it's just an electron there. And if it's a nucleophile, it's going to be negatively charged. Okay, so let's count how many electrons there are. Let's use this. So each bond has 2. 1, 2, 3, 4, 5, 6. So this has 6. So the answer is either A or B. This one, 1, 2, 3, 4, 5, 6, plus that one. So this one is 7. So the answer is A. Let's just check. This one is 1, 2, 3, 4, 5, 6, plus D2, 7, 8. So the answer is 27A. All right. Next one, 27. This one's a horrible one, I must admit. Compound Z, C7H13Br, has two chiral centers. A sample of Z contains all 4 possible optical isomers. The sample of Z reacts with hot ethanolic sodium hydroxide to produce a mixture of only 3 isomers. 2 of these isomers are optical isomers of each other. What must the formula of Z be? Right, now, if you react it with ethanolic sodium hydroxide, the HBr is eliminated, isn't it? So we're going to get rid of the Br, so that goes. And the hydrogen next to it, so you're going to get that. Okay, now, if this is the answer, you get this. Okay, there's 1 isomer there. All right, and this has, because this is chiral, there's 2 optical isomers of this. And if the Br goes and the hydrogen here goes, this is no longer optical. So that all of that goes. So this is the other isomer, but it's not optical. So this gives 3 isomers. Okay, 2 of them are optical if the double bond is there, and if the double bond is there, it's the non-optical one. Okay, so this is the answer A. Let's have a look at B. You'll get 1 there. All right, if it's there, you'll get that one. There'll be 2 optical isomers, but it could also be down here, that one, and that will also have 2. So this one will have 4 isomers, so it can't be B. If it's this one, you can get that, which you'll have. This again is optical, so you'll get 2 of those times another 2. If you, if you get down there, so this is 4 as well. And I think there's more there, isn't there? So you get 1, 2, 3. You get 2 there and 2 there. Okay, I think you might get another 2 somewhere. And where have I done? You've done that one. So there's 2 of that, 2 of that. I think that's 4. I think I can. There might be another one lurking around there. But anyway, you don't get 3, so it's not that one. If it's this one, you get rid of that. You won't get an isomer there, you'll get 1 there. You'll get a double bond there. You can't have a double bond there because there's no hydrogen to take off. So if the C, for this one, this will go, you'll get a double bond there. And there's no optical isomers here, no optical at all. So it can't be D. I'm a bit confused about C. I think there's 6 there. I can only see 4 at the moment. So it goes there. You get 1, 2. Goes there, 3, 4. I can see 4, but I think there's more. It feels like there should be more there. So the answer is A anyway. It gives us 3 isomers. Okay, so that's 28 done. Which reaction is a redox reaction? Ethane nitrile heated under reflux with dilute HCl. Ethane nitrile is this. There it is. Okay, and if you heat it under reflux with dilute hydrochloric acid, you'll get the carboxylic acid, won't you? Yeah. Okay. That could be described as an oxidation, couldn't it? Because we're adding oxygens there. I'm looking at the oxidation number of the carbon there. This is 0 there. Anyway, we'll figure that out in a minute. Ethanol. Oh, it's obviously this one, isn't it? It's obviously that. So this isn't regarded as an oxidation. Ethanoic acid reacted with sodium. Obviously, the sodium becomes Na+, and that's a redox reaction, isn't it? All right, so the answer is 37C there. Let me check. I've got the answers here. So let me see if I got 28 right. Yeah, 28 is A. 27 is A. Yeah, I got that right. And 26 is C. Yeah. So I reckon 37C. Let's have a check. Yeah, it must be that, mustn't it? Because the sodium loses an electron. All right, cyclohexane is shown in the diagram can form an addition polymer. There you go. Which structure represents this? Okay, so if you've got 2 of these, let's try and draw this nicely. Draw 2 next to each other. Okay, and then let's draw 3. Okay, so what's going to happen is the double bond's going to open up, and you're going to get a bond formed between that carbon and that carbon. This double bond opens up, and you're going to get a bond formed there, and this double bond opens up, and you're going to get a a bond from there. So that's the structure of the polymer. It's not this because it forms kind of at positions 1 and 2, so it can't be this one. This one, look, it goes in there, comes out there. This is 2 away. This is 3 away from that to that. This is 2 away from that to that. This is the right type, isn't it? Because it's forming like this. Okay, now if you drew this one on top, oops, you see something like that, it would be this, wouldn't it? All right, and got rid of it down here. We've just drawn an angle difference, and it's not going to be D. D's rubbish, so the answer is C there. Hope that makes sense. If there's any problems, give me a shout and I'll go over them again.